Okay, we're going to look at motion problems in this video. You need to know that the distance equals rate times time gives us the simple equation d equals rt. There are two types of motion problems that we're going to look at. They have two simple equations, d1 equals d2 or d1 plus d2 equals distance total. Now, for this type of problem, d1 equals d2, you are either going to have two guys who are starting, and maybe one's going faster and the other one's going slower, but eventually one catches up to the other one and they go the same distance. The lines show me the distance that was traveled. Those are called catch-up problems. The other type of problem that will give you d1 equals d2 is a round trip problem. You go one place, you turn around, you come back to where you started. Notice that given the line segments here, you have the same distance traveled. These are round trip problems. Alright, for the distance 1 plus distance 2 equals distance total, you generally have one of three pictures. You either have two guys starting at the same place going in opposite directions, and at some point they're going to be a total distance apart. Or you might have them starting apart from each other and coming towards each other. But again, you'll have some kind of a total distance, and you'll have segments representing d1 and d2. The third type of problem is when you have two guys starting at the same time. They both take off, and because one is going faster than the other, he's going to be out ahead of the first guy. So you have a distance here that you need to consider, and that's the distance that the first guy is ahead. In this case, this would be considered distance total because I have two shorter distances that add up to a third distance. So in all three of these pictures, I have two smaller distances that add up to a total distance. Alright, let's look at our first problem. Sue leaves Lewiston for Clarksville 388 miles away and drives 52 miles per hour. Monica leaves Clarksville for Lewiston at the same time and travels 45 miles per hour. How soon will they meet? So we're trying to find the number of hours until they meet. Now, step 2 is going to look different than it has for other problems. I have Sue and I have Monica. I am going to make a table, a little chart here, a row for each person that's traveling, and then along the top I'm going to have rate times time equals distance. So I'm going to fill in my first four boxes using the problem. So first of all, it says Sue is going 52 miles per hour. That is her rate, so put it in the rate box. It says that Monica is going 45 miles per hour, so put that in her rate box. Now time is what we're trying to find. That's our variable, so put a t here and a t here. Alright, now to fill in the distance column, please do not look at anything that's in your word problem. Look only at your table. Do the multiplication that it tells you to do, rate times time. So for the distance for Sue, I've got 52 times t. For Monica, I've got 45 times t. Alright, now let's draw our picture. I have got Sue over by Lewiston heading this way. And then I have got Clarksville over here, and that's where Monica is. And she's heading this way. Now it tells me that the two cities are 388 miles apart. Alright, so now what we need to do is we need to take our distance column over here and put those on my picture. So Sue, her distance was 52t. For Monica, it was 45t. Now you should be able to tell from this picture what my equation is. I have got two shorter distances adding up to a total distance. So my problem is going to be d1 plus d2 equals distance total. So I'm going to have 52t plus 45t equals 388. And that's the equation that I'm going to solve. When I solve the equation, I end up with t equals 4. Now, make sure that you go and understand from up here what t was. T was the time that they both traveled, and that's what we're trying to find in step 1. So you write your conclusion, therefore, they meet in 4 hours. Okay, let's look at the next one. Brandon and Shanda walk to Grandma's house at a rate of 4 miles per hour. They ride their bikes home at 8 miles per hour over the same route. It takes 1 hour longer to walk than ride. How long did it take to walk to Grandma's house? So we're looking for the number of hours to walk to Grandma's house. Now let's look at the picture that we have. I have both kids starting on a walk to Grandma's house. Okay, so here's Grandma's house. Now, they're walking there, so we'll put a W for walk, but when they come back, they are on bikes. Coming back, they're biking. Now, this is a round trip problem because they're going all the way to Grandma's house and then they're turning around and coming all the way back. So on our chart, I don't need to make a line for Brandon and for Shanda because they're together. Instead I need to say maybe walking and biking or to and from, but I need my table to be the same as it was before. Rate times time equals distance. Alright, let's fill in our first 4 boxes. Looks like when they walk, they're going 4 miles per hour, and when they ride their bikes, they're going 8 miles per hour. So how long are they going? Well, I don't know how long it takes to walk. That's my t. But I know it takes 1 hour longer to walk. So if I put a t in this box, the biking amount of time has to be 1 hour less. So I would put a t minus 1 in that box. Now, don't look at your problem, just look at your table and fill in the D column. I have 4 times t, and then I have 8, and make sure you get this in parentheses. It's 8 times the quantity, t minus 1. Alright, now as we did in the last problem, this information is what goes on your picture. Walking, their distance was 4t. Riding, their distance was 8 times the quantity, t minus 1. So over here for step 3, I've got distance 1 equals distance 2. So fill it in with your 4t, and on the right side you would have 8 times the quantity, t minus 1. Now solve that. Alright, now I've solved the equation and I get t equals 2. So go back up to your table. We need the time for walking, and that's t. So my answer is 2. It took 2 hours to walk to Grandma's house. Ted runs 2/3 as fast as Frank. In 2 hours, Frank runs 8 miles further than Ted. How fast does each run? Before we do our table, let's take a look at what's happening. I've got Ted and I've got Frank. They start at the same time. Frank runs faster because he is out ahead. He's 8 miles further than Ted. So at some point in time, there's going to be 8 miles between the two guys. Alright, so this should give us an idea already of what our equation is going to be. Let's come over here and make our table. I've got Ted and I've got Frank. Rate times time equals distance. Rate times time equals distance. Alright, Ted runs 2/3 as fast as Frank. I don't know how fast Frank runs, so I'm going to put an R there. I know that Ted runs 2/3 of R. Okay, now my time for both of these, they run 2 hours. They start at the same time, and after 2 hours, Frank is 8 miles ahead of Ted. So don't look at your problem, just fill in your chart. I've got 2/3 R times 2, which means I have 4/3 R, and I have 2R. Those need to go, those amounts need to go on my picture. So Ted, his distance is 4/3 R, and Frank's is 2R. Now you can tell by the picture that my equation, I've got two distances adding up to a third. The distances that I'm going to add up to the third are the 4/3 R and the 8. So I've got 4/3 R plus 8 equals 2R. Alright, now when I go to solve that, I would prefer to clear the fractions, and so to do that I'm going to multiply all the way through by 3. Both sides of the equation, because then on this I get 4R plus 24 equals 6R. This is a pretty easy equation to solve. I need to subtract 4R from both sides, and I get 24 equals 2R, which means R is 12. Okay, so that is Frank's rate. We also need 2/3 of that. So what's 2/3 of 12? That's 24/3, which would be 8. Alright, and you write your conclusion. So we get R equals 12 when we solve that, and 2/3 R equals 8. So Ted runs 8 miles per hour, and Frank runs 12 miles per hour. Okay, here's our last problem. A passenger train leaves Charleston heading east at the same time a coal train leaves Charleston heading west. The passenger train travels 23 miles per hour faster than the coal train, and in 4 hours the two trains are 412 miles apart. What is the speed of each train? Alright, I've already started with the picture. I've got my coal train headed west, my passenger train headed east. And at some point in time, after 2 hours, the distance between those two trains is going to be 412 miles. Alright, let's draw our little chart here. I've got the coal train and the passenger train. And I've got rate times time equals distance. Now it says the coal train, the passenger train travels 23 miles per hour faster than the coal train. So I don't know anything about the coal train, so I'll start with R. And I know that the passenger train is going 23 miles per hour faster, so that would be R plus 23. It says in 4 hours the trains are 412 miles apart, so both trains are traveling for 4 hours. Okay, now don't look at your picture and just fill in the chart from the chart. So 4 times R and 4 times the quantity, R plus 23. Alright, as we've done before, those amounts have to go over here. So the coal train has a distance of 4R, and the passenger train has a distance of 4 times the quantity, R plus 23. You can tell by the picture that my equation is going to be D1 plus D2 equals distance total. So fill that in with the 4R plus the 4 times the quantity, R plus 23, and that equals the total distance, which is 412. Now solve that. Okay, I've solved the problem, and I got R equals 40. That means R plus 23 would be 63. We are trying to find the rate of both trains, so we need the quantities for both of those rate boxes. So my conclusion would be the coal train is going 40 miles per hour, and the passenger train is going 63 miles per hour.